All right, so this is 4.4 exponential and logarithm equations. So everything we've been doing is going to kind of lead up to this this section because we're actually going to start solving. And so we're going to use this thing called the one-to-one property right here. And so basically that's going to be that if you can get the bases to be the same on each side, then you can cancel them out and then just set the exponents equal to each other. And so we're just going to have to do some manipulations, and some of the manipulations are going to require some exponent rules. So hopefully y'all remember the power rule. So if you have a power to a power, if you had, x, well, let me just do an example right here. So if you had like x to the third raised to the fourth, that actually becomes x to the 12th power. You would multiply them together, okay? And then the negative exponent rule, if you have a negative exponent, you just need to take the reciprocal to make the exponent positive. And so we might see that rule pop up a couple times there. And so, all right, so let's go ahead and get started. So on this first one, I'm assuming that if you had to, you could solve this one just by trial and error. You could just try some different values and figure out what 2 to what power would give you 64, and that's fine. I mean, that's basically what we're about to do. But I'm going to go ahead and try to get the bases to be the same, because as we move forward, they're going to get more challenging, and that's the approach you want to take. So looking at 64, let's see. You could just start kind of counting off. You could say, okay, 2 times 2 would give you 4. Then if you double that, that's 8. Then 16. 32, and then 64. So if you count how many times you doubled it, let's see, we started with a 2, so 1, 2, 3, 4, 5, 6. So 64 must be equivalent to 2 to the power of 6, okay? And so then using the one-to-one property, you cancel those out, and you get that x equals 6. So I understand that what I just kind of did there might not have been absolutely necessary to solve this problem. But like I said, moving forward, you're going to get to more challenging problems to where you have to use that property. So that's why we're doing a couple of easy ones first. So 3 is basically the same thing as number 1. So right here, you got 5 to the x. And then 25, that's the same thing as 5 times 5 times 5. Okay, so that'd be 5 to the third power. So then we can cancel out the 5s, and we get x equals 3. Not too bad. Okay. So now you can see on this next one, it does start to get a little bit more challenging. I mean, it's not terrible, but there's a little bit more going on in that exponent. So once again, we need to somehow get the 32 into 2 to some power. So let's see, 2, 4, 8, 16, 32. So you can even look back here. So 1, 2, 3, 4. It took 5 times to do that. This would be to the power of 5. Okay, and so then now we can cancel those out. And so you're going to be left with 2x minus 1 equals 5. And then just some simple algebra from here. So let's see, you add 1 to both sides. So you're going to get 2x equals 6. And then we'll divide by 2, and we get x equals 3. Okay. All right. All right, so we're going to move on to 7 in just a second. Okay, picking up off of number 7. So basically, just like the last one we just solved, so we're going to look at 64. And so if you look at 64, that'd be 4 times 4, that would give you 16. Then if you multiply by 4 again, that's 64. So it took 3 multiples of 4. So that'd be 4 to the third power equals 4 raised to 2x minus 1. Cancel out those 4s, so we get 2x minus 1 equals 3. Then we'll go ahead and add 1, add 1. That cancels out. 2x equals 4. We'll divide by 2, divide by 2. X equals 2. Okay, so that's not too bad. When we look at 9, this one's going to kind of be a little different, because if you look at the bases, you can't really, to turn 32 into an 8, that would be pretty challenging, and So what we're going to actually do here is adjust both bases, okay? And so that's where that power rule is going to come in a moment. So 32, let's see, 2, 4, 8, 16, 32. So that should be 2 to the 5th power, okay? But then it still has that power of x right there, so don't forget about that. So 32, I changed it to 2 to the 5th power. And then 8, we're going to change that to 2 to the 3rd power. Now, before I start trying to cancel anything out, I want to go ahead and do the power rule. So that's why we reviewed that. So this actually becomes 5x. And then we got 2 to the 3rd. So 5 times x, 5x. Now we can go ahead and cancel out the 2's. So we get 5x equals 3. Divide by 5 on each side. So we get x equals 3/5. Okay. All right, so then 11, we'll take a look at 11 here. 11 is going to be a lot like number 9. So if you look right here, we're going to adjust this to 3 squared raised to the power of x equals 3 to the 3rd power, which is the same thing as 27. And so then this will become 3 raised to 2x once you do the power rule right here. And then right here, this is going to be 3 to the 3rd. Then now we can cancel those out. So 2x equals 3. And divide by 2, x equals 3/2. And there you go. All righty then. All right, if you need a moment, you can pause it, but I'm just going to keep moving forward. Okay, so this one's a little tricky right here. So you know you've got a base of 3 right there. You probably don't want to change that. So we're just going to leave that as 3 raised to 1 minus x. But I need to somehow get this to a 3. So we're going to think about this. So 3 to what power would cause me to become 1 over 27? Okay, so what power would cause me to like become a reciprocal and then to be a 27? Take a minute and think about it. Well, if you look back up at the properties, negative exponents cause you to take the reciprocal, so we're probably going to have a negative. It's probably going to be negative. And then how does that 3 turn into 27? Well, we saw that earlier. 3 to the 3rd power is 27. So this must be an exponent of negative 3. So 3 to the negative 3 power is 1 over 27, and you could try it if you wanted to. Okay, so back to our problem. We're good to go now. So we cancel out our 3's. So we're going to have 1 minus x equals negative 3. And then now we need to go ahead and solve for x. So we'll subtract 1, that cancels out. Negative x equals negative 4. So then we'll divide by negative 1 on both sides, and so we should end up with x equals 4. Okay? All right. Okay, so let's see. On this next one, this one's kind of tricky. And so something you need to remember is if you have the square root of some number, that's the same thing as raising it to the power of 1/2, okay? And if you have the cube root of something, that's the same thing as raising it to 1/3, okay? And those are going to be things that you do need to know. They'll kind of come around every once in a while in this chapter, okay? So that's what we're going to do on 15. So the left side's going to stay 6 raised to x minus 3 all over 4. The right side, we're going to change it to 6 to the 1/2 power because it's the same thing. And so then now we'll go ahead and cancel out the 6's. So then we're going to have x minus 3 all over 4 is equal to 1/2. And then from here, it's just going to be algebra. So you want to solve for x. So let's just go ahead and get rid of the fraction. So if we multiply by 4 on both sides, it cancels out that. And we're left with x minus 3 equals, like, let's see, 1/2 of 4 is 2. We're almost done with the problem. All I have to do now is add 3, add 3. That cancels out, and we're going to get x equals 5. There we go. Okay, our last one of this type. It's a lot like the one above this one, number 11. You got to adjust both bases. And so let's see. So for the 8, that's the same thing as 2 to the third power. And then just remember, you still have the x plus 3 up here. And then that 16, that's the same thing as 2 to the fourth power. And just remember, you still have the x minus 1 up there. So on this one, you have to be a little careful because when you do the power rule, power to a power, when you multiply this, that 3 is going to multiply to both of these, and that 4 is going to multiply to both of those. So we're going to end up with 2 raised to 3x plus 9 is equal to 2 raised to 4x minus 4. Okay, so you got to be a little careful about that. So a lot of times students will only put it with the x. So make sure it goes to all parts of that exponent there. All right, so then now let's see. We're going to cancel out our common bases. So we'll cancel here, cancel there. There we go. And so we're going to end up with 3x, ooh, this is getting a little glitchy on me, plus 9 equals, okay, hopefully I can get through this problem without it glitching anymore. We'll see. All right, and I mean, if not, it's fine. This is pretty simple algebra. Y'all should be able to do this. So we've got our equation here, and so let's see. We'll go ahead and subtract 3x here, subtract 3x. So we get 9 equals x minus 4. And then we're going to go ahead and add 4. Add 4, that cancels out. So we're going to get 13 equals x. All right, that's it. So that's page 1 of 4.4.